Researchers have shaken up a once-accepted timeline for cataclysmic events in the early Solar System. About 4.5 giga-anum, or billion years ago, as a large disk of dust and ice collapsed around our newly formed star, planets and smaller celestial bodies were formed. What followed was a chaotic and violent period of collisions and impacts as the familiar 8 planets carved out their orbits to resemble the balanced system we observe today. Geological and geochemical records indicate that after about 600 to 700 million years after formation, but still early in the Solar System's existence, the Earth-Moon system experienced a period of frequent and cataclysmic impacts from asteroids and other bodies. This period is dubbed the Late Heavy Bombardment (LHB) period. It was once thought that this period had a relatively sudden onset, but a research team at Hiroshima University and the University of Tokyo in Japan have found evidence that this bombardment period may have started much earlier, and decreased in intensity over time. The team published their findings on August 26 in Earth and Planetary Science Letters. According to Apollo's lunar rock studies from the 1970s, the Earth, Moon, and the entire inner Solar System are thought to have suffered from numerous meteoritical impacts at around 3.9 Ga. This event is regarded as a key process during the early evolution of our planet, said Mizuho Koike, an author of the study and an assistant professor from the Graduate School of Advanced Science and Engineering at Hiroshima University. To settle this debate, a solid database of the impact ages is required. The team started building this database using rocks found on Earth that originated from a large, ancient asteroid, called Vesta, to see if they could corroborate the timeframe of the LHB period. If the Solar System indeed experienced the LHB period roughly 3.9 Ga, Vesta, like Moon, would likely hold similar evidence of such an event around the same time period. What the team found was a record of impacts 300 to 500 million years earlier than expected. We found that the rocks from Vesta recorded the multiple impacts that occurred between 4.4 to 4.15 Ga, clearly earlier than the predicted peak of LHB at approximately 3.9 Ga. In contrast, no impact evidence was identified at 3.9 Ga or later. These findings suggest that Vesta, and probably other asteroids as well, did not record the LHB. Instead, they experienced massive impacts at the earlier stage, said Koike. It is still unclear what this means for the LHB period as a whole, but Koike and her colleagues plan to further investigate the chronology of the early Solar System. To verify such an examination, we are planning to investigate the impact histories on other asteroids and planetary materials by applying our present analytical techniques. By doing so, the team may be able to add to their database and, ideally, peer with more clarity into our Solar System's dist. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.